The human brain is the most complex object in the known universe, at least to us humans, and for good reason. This 3-pound mass of tissue, containing over 86 billion neurons and 100 trillion synaptic connections, is responsible for every thought, feeling, and action that we have. But for most of human history, the prevailing view in neuroscience was that the adult brain was largely fixed and unchanging. We were thought to be born with all the brain cells we'd ever have, and once they were gone for good. The brain structure was seen as immutable and hardwired by our genetics and early life experiences. Luckily, this disempowering view of our brains has been disproven just over the last few decades. Emerging research shows that our brains remain plastic throughout life, constantly reshaping their neural networks in response to various stimuli. This capacity for change is known as neuroplasticity and is the key to our incredible ability to learn, adapt, and overcome challenges as humans. It's what allows us to acquire new skills, form new memories, and bounce back from traumatic brain injuries. In this video, we'll explore cutting-edge research revealing the brain's lifelong capacity for change and unpack the neural mechanisms that make this change possible. We'll explore how our thoughts, behaviors, and experiences leave tangible traces on brain structure and function, and we'll detail evidence-based techniques to harness neuroplasticity, sharing practical tips to rewire your brain for enhanced cognitive performance. Welcome to the Genius Protocol, where we explore the science, philosophy, and psychology of the genius mind. Part 1. A brief history of neuroplasticity. The notion that the brain can change its structure and function in response to experience is a new one. In the 1990s and 2000s, new brain imaging tools were developed, specifically magnetic resonance imaging, MRI, and positron emission tomography, PET. These scans allowed scientists to watch the living brain in action for the first time. They could see brain activity and connections changing in real time in response to experiences and therapeutic interventions that they applied during their research. This was a revolutionary era which proved that the adult brain was far more adaptable than previously believed. Michael Merzenich showed that when monkeys lost a finger, the brain areas for the remaining fingers grew larger to compensate for the loss. Edward Taub developed therapies that rewired stroke patients' brains to restore lost movement patterns. Alvaro Pascal Leon used magnetic stimulation to prove that the visual cortex in blind patients had actively rewired itself to process touch and hearing instead of visual perception. Together, this research transformed our view of the brain from a fixed, hardwired machine to a dynamic, ever-changing ecosystem. We now understand that our experiences continually shape our brains throughout life. This concept was called neuroplasticity. Part 2. Key mechanisms of neuroplasticity. So how exactly does the brain change in response to our experiences? What are the neural mechanisms that underlie this incredible capacity for plasticity? Neuroscientists have identified several key processes that mediate brain change. 1. Synaptogenesis. One of the primary ways the brain changes is by forming new synaptic connections between neurons. This process, known as synaptogenesis, is especially prolific during early brain development, with the average human infant forming over 1 million new synapses per second in the first few years of life. However, we now know that synaptogenesis continues through adulthood. Every time we learn something new, whether it's a fact, skill, or habit, our brain cells fire together in new patterns. When new neurons fire together repeatedly, they start wiring together more strongly, forming new synaptic links. This process is mediated by a host of molecular signals, including neurotropic factors like brain-derived neurotrophic factor, BDNF. BDNF is a protein that promotes the growth and differentiation of new synapses and the survival of existing ones. It's been called miracle grow for the brain because it nourishes and strengthens neural connections. Levels of BDNF increase in brain regions undergoing active synaptogenesis, like the hippocampus during spatial learning or motor cortex while mastering a new physical skill. Interestingly, BDNF is also upregulated by physical exercise, which may partly explain the cognitive benefits of staying active through life. Essentially, the more you challenge your brain to learn and the more you move your body, the more fertile ground you create for new synaptogenesis. 2. Synaptic pruning. Plasticity isn't just about the brain gaining new synaptic connections, it's also about losing them. The flip side of synaptogenesis is synaptic pruning, the selective elimination of unused or underused synapses. Pruning is the brain's way of streamlining neural circuitry for maximum efficiency. Just like a gardener prunes dead branches to promote the growth of new healthy ones, the brain prunes weak synapses to strengthen well-used neural pathways. It's a classic use it or lose it situation. Synaptic connections that are actively engaged get preserved and reinforced, while those that aren't wither away. Synaptic pruning is particularly active during certain developmental windows, like adolescence, when the brain is consolidating neural networks and specializing for adult functionality. But it continues throughout life as the brain fine-tunes its circuitry based on our experiences and behavior patterns. This process is mediated by immune-like cells in the brain called microglia, which actively survey the brain and engulf weak synapses marked for elimination. It's also influenced by competition between neurons, with the most active neural pathways winning out and claiming more synaptic territory. Pruning is thus a key way the brain optimizes itself and adapts to our actual lived experience over time. The neural pathways we use the most, whether it's playing an instrument or mulling anxious thoughts, get preferentially strengthened and preserved. So in a very real sense, neurons that fire together wire together, and those that don't won't. 3. Neurogenesis. For a long time, neuroscientists believed that we were born with all the neurons we'd ever have. It was thought that unlike most other cells in the body, brain cells couldn't regenerate or produce new neurons. Once they died, they were dead forever. However, groundbreaking research in the 1990s completely overturned this dogmatic belief, showing that adult mammalian brains could indeed birth new neurons. This process was called neurogenesis. Using techniques that label dividing cells, researchers found pockets of neural stem cells in specific brain regions that continued producing new neurons throughout life. The most well-studied of these neurogenic niches is the hippocampus, a seahorse-shaped structure crucial for learning and memory. Studies have shown that thousands of new neurons are born in the human hippocampus each day, migrating and integrating into existing neural circuits. These newborn neurons are especially plastic, with enhanced excitability and capacity for synaptic strengthening. Fascinatingly, the rate of hippocampal neurogenesis is modulated by our experiences and behaviors. Conditions that promote neurogenesis include 1. Physical exercise, especially aerobic and sustained activity. 2. Cognitive stimulation, like learning new information or skills. 3. Sex and reproductive hormones like testosterone and estrogen. And 4. Antidepressant medications such as SSRIs could potentially contribute by their mood-boosting effects. On the flip side, neurogenesis is impaired by 1. Chronic stress, which floods the brain with cortisol. 2. Sleep deprivation, which disrupts memory consolidation. 3. Alcohol and drug abuse, which can suppress neural stem cell proliferation. And 4. Aging, with neurogenesis declining steadily as we approach later age. So, while neurogenesis occurs on a much smaller scale compared to early brain development, it remains an important mechanism of adult brain plasticity. By adopting a neuron-friendly lifestyle, we can promote the birth and survival of these highly plastic cells, rejuvenating brain circuits and potentially boosting our cognitive function. Part 3. Harnessing neuroplasticity for cognitive enhancement. So far, we've seen how the brain remains remarkably plastic throughout life, constantly rewiring itself in response to our thoughts, behaviors, and experiences. But how can we proactively harness this innate capacity for change? What can we do to intentionally shape our brains and cognitive abilities? Here are some key evidence-based strategies to promote positive brain plasticity. 1. Engage in lifelong learning. The brain is like a muscle. The more you challenge it, the stronger and more flexible it becomes. Engaging in mentally stimulating activities, especially those that require focused attention and active processing, is one of the best ways to promote brain plasticity. This could involve learning a new language or musical instrument, tackling puzzles, brain teasers, and strategy games, taking up a cognitively demanding hobby like chess or computer programming, pursuing higher education or professional development courses, or reading challenging books and discussing them with others. The key is to consistently push yourself outside of your mental comfort zone, grappling with concepts or skills that don't come easy. This kind of desired difficulty is what triggers the brain to form new synaptic connections and strengthen the existing ones. Crucially, the learning process should be spaced out over time, with regular practice sessions interdispersed with periods of rest. This kind of spaced repetition leverages the brain's natural consolidating processes, allowing new neural pathways to solidify and integrate with existing knowledge networks. 2. Embracing a growth mindset. Our beliefs about the nature of intelligence and talent shape our approach to learning and ultimately our cognitive abilities. Individuals with a fixed mindset see their abilities as innate and immutable, kind of similar to what they experienced before we discovered all of the new recent adaptations about the brain. They think that you're either smart or you're not, and there's not much you can do about it. In contrast, those with a growth mindset view skills and smarts as malleable qualities that can be cultivated through dedicated effort. Extensive research by Stanford psychologist Carol Dweck has shown that embracing a growth mindset can have profound effects on motivation, resilience, and achievement. When we view challenging learning tasks as opportunities to grow rather than threats to our ego, we're more likely to persist in the face of setbacks and adopt mastery-oriented strategies. On a neural level, the growth mindset interventions have been shown to alter brain activity in regions associated with error monitoring and cognitive control. Individuals taught to view mistakes as learning opportunities showed enhanced neural responses to corrective feedback, indicating greater openness to altering entrenched patterns. To cultivate a growth mindset, notice your inner monologue around learning, replacing fixed mindset statements, "I'm just not a math person," with growth-oriented statements. "Math is challenging for me, but I can improve if I practice." Frame mistakes and failures as essential steps on the path to genius. Emphasize the process of learning over the end result. Not everybody is going to be Albert Einstein, but everybody can study physics. Celebrate effort, strategy, and incremental progress rather than sheer talent or intelligence, and study the lives of famously talented individuals, noting their dogged persistence and dedication to their genius craft. By internalizing a growth mindset, we open ourselves up to change. We come to view our brain as a dynamic system to be actively shaped, not as a static entity that we were simply endowed with. And this shift in perspective aligns with the science and can unleash the power of our neuroplasticity. Part 3, the benefits of physical exercise. We often think of exercise as merely a way to strengthen our muscles and our cardiovascular system. But it turns out that physical activity, especially aerobic sustained exercise, is one of the most potent promoters of positive brain plasticity. Exercise benefits the brain in multiple ways: increasing blood flow, delivering oxygen and nutrients to hungry neural tissues, stimulating the production of neurotropic factors like BDNF, which support the growth and survival of brain cells, boosting neurogenesis, especially in the hippocampus, leading to improved learning and memory, modulating neurotransmitter levels, enhancing focus and mood, and reducing inflammation and oxidative stress, which can damage neural connections. Numerous studies have shown that regular physical activity can improve cognitive function across our lifespan. It's associated with better attention, processing speed, memory, and executive function in children and adults. It's even been shown to reduce the risk of age-related cognitive decline and neurodegenerative diseases like Alzheimer's. To get the brain-boosting benefits of exercise, use this protocol. Aim for at least 150 minutes of moderate aerobic activity or 75 minutes of vigorous activity per week. Include a mix of cardio and strength training exercises. Find activities that you genuinely enjoy, whether it's dancing, swimming, hiking, or team sports. Exercise with others to harness the social and emotional benefits, and gradually increase the intensity and duration of your workouts over time. By consistently challenging your body, you provide an enriched environment for your brain to adapt and thrive. You quite literally build a better brain by moving your body. 4. Practice mindfulness and meditation. In our fast-paced 24/7 world, our attention is constantly bombarded by distractions. We're forever multitasking, juggling work, relationships, and leisure in a frantic dance. This chronic busyness can take a toll on our cognitive abilities, eroding focus, memory, and mental clarity over time. An antidote to this attentional fragmentation is the practice of mindfulness, the simple yet challenging act of focusing our attention on the present moment, on purpose, and without judgment. Mindfulness can be cultivated through formal meditation practices like focusing on the breath or bodily sensations, as well as informal, mindful moments throughout the day. A wealth of research has documented the brain-changing effects of mindfulness training, increasing gray matter density in regions associated with attention, learning, and memory, like the prefrontal cortex and hippocampus. It strengthens neural networks involved in self-regulation and emotional resilience. It promotes neural integration, enhancing communication between distant brain regions, downregulates activity in the amygdala, the brain's fear and anxiety center, and slows age-related thinning of the cerebral cortex. Essentially, mindfulness seems to train the brain to more skillfully notice and respond to external stimuli, rather than getting caught in reactive rumination patterns of thought. It cultivates a kind of mental flexibility that allows us to more nimbly navigate life's challenges. I'll make more videos about mindfulness and meditation in the future, but here's some quick tips if you want to get started. Set aside at least 10 to 20 minutes a day for a formal meditation practice. Use guided meditations if you're a beginner. Focus on the breath, body, or sounds as anchors to the present moment. Notice when the mind wanders and gently redirect it back to the present. Bring mindful attention to everyday activities like eating, walking, or active listening. And make sure that you practice self-compassion, meeting thoughts and emotions with curiosity and acceptance instead of judgment, fear, and guilt. By training your brain to rest in the present moment, we gave it a much-needed respite from the tyranny of constantly being active. In those spaces of stillness, the brain's plastic potential can blossom. The discovery of the brain's lifelong capacity for change is arguably the most exciting development in modern neuroscience, and why I chose to make it the first video in the new Genius Protocol channel. It's overturned the notion that we're stuck with the brain we're born with, and opened up tremendous possibilities for cognitive enhancement and rehabilitation. In this video, we've seen how the brain changes through the formation of new synapses, the pruning of unused connections, and even the birth of new neurons. We've explored how our thoughts, behaviors, and experiences leave tangible traces on neural structure and function. And we've unpacked practical, evidence-based strategies to harness neuroplasticity, from engaging in learning to physical exercise to cultivating a growth mindset and practicing mindfulness and meditation. But perhaps the most exciting implication of neuroplasticity is the incredible power it gives to shape our own lives. We're not passive or biology. We're active sculptors every day with every thought, every action. We're subtly but substantially altering of our being. This is a great opportunity, and on one hand, it means that we have the capacity to prepare our brains for the better, to cultivate qualities like creativity, empathy, and compassion. Practices that promote cognitive growth and flexibility. On the other hand, it means that we we steward our plastic potential. The same mechanisms that enable positive brain change are vulnerable to negative ones. Neural pathways that are, whether it's circuits underlying addiction or anxiety, can become deeply entrenched over time and hard to break. We must be intentional about the mental habits and patterns we reinforce. Ultimately, the science of neuroplasticity empowers us to become more active participants in our own cognitive destiny. It invites us to approach our mind as a garden to be carefully tended to and not destroyed. Of course, changing the brain is not simple and it's not easy. It requires effort, consistency, patience, and a willing to push past difficult challenges, failure, and resistance. Our entrenched patterns of thought and behavior often come from childhood and are very difficult to break. Sometimes they feel like mountains that we have to move, solid and hard to shift, but we have the power to do so. As the great psychologist William James once said, "The greatest discovery of my generation is that a human being can alter his life by altering his attitude." We now know that it's not just our attitudes, but our very brains that can be altered through concerted effort and attention. If you enjoyed this video, make sure to like the video, subscribe, and let me know in the comments below what topics you'd like to see me discuss next in our quest for becoming a genius. Thanks for watching. Peace.